In the last video, we have already actually developed a code for random motion. You just copy paste the random motion into random motion collide. Now we're going to move forward. I have already explained in like particle motion video 1 how to just make two particles, plot two particles. You just have to specify its coordinates. I'm going to specify its coordinate as 0, 0, 0. Pretty much everything else would be then accordingly. For the checking part, let's see if it works. Stay in time, let's take time. LC, where I have mentioned LC. Okay, I just done this one. Okay, now let's see if it works. Oh my goodness, it's taking time. Okay, one particle is here, another particle is here, so it's moving. Good. Okay, this one we just developed in the last video, but I have just made little change to actually include number of particles. I have just included this for loop for going size for loop that will do iteration for 2 times or 3 times the number of particle time, whatever the number of particles is. You're going to use this for I 1 to size of x comma 2. If coordinate is only one particle is there, so one x-axis is there, one x-axis coordinate is there, then size will be 1. It will just happen for one time. So same thing for number of particles. This loop will go on for number of particles, and you just changing this. I have also done indexing of every coordinates. So this is the only thing I have changed from the last random state function. This is, we'll do it. Yep. And I'm going to make it a little bit like this time. I'm giving my coordinates of x, y, and z, but I want random coordinates of x, y, and z. Okay, so I'm going to use this function rand I there. Random motions, and the random motion should be like in between the bounds. So I'm going to create first number of particles. Let's create one and create bounds of the spaces. Here is 0, 20, 0, 20. So random size should be number of rows. Rows should be only always 1, but column should be according to number of particles. That will be actually equal to n. So 1 comma n should be the size of the random coordinate developed. Yep. And this bound should be given by this one minus 1, like in between which number, in between which range you want your coordinates to be. And here you can also do the same thing to this part, bounds as well, px, p1, and bz. Number of particles 1. Let's see if it works. Yep, one particle works. So 100 iteration. Yep, 100 iteration is too much. It's 50. For now, just we're going for increase number of particles as 2. Now particles 2. Okay, it's going very nicely. It's working. So in this video, we just want loop to end when two particles collide. Okay, so we don't need count iterations from number of counts. We didn't need this part. We need reason. Should first of all keep as false. Logic or reason. It's called logic. I will create a logic when two particles collide. What will be the logic there? While logic is equal to false, this should keep on going. So this will run for infinity. It won't stop. Okay, it's making good. Now create a logic. Now this is the most important thing. What would be the logic? First of all, we're going to create a position vector of a particle. X dash, the X transpose, Y transpose, and Z transpose. What I mean by that, like each particle will be given in position vector B matrix. It will be given along rows. I will show you what I mean. So like this position, what V is the position vector of the particles. This is particle 1, first row is particle 1, second row is particle 2, and these are x, y, and z axes. So if any of the two, or actually let's change it to 3, any two, or when any two position vectors are same, this loop should stop. So what will be the logic for that? There's a function called as unique function b. As soon as any two elements of the matrix V will be same elements. I'm talking elements. It will give a matrix without those unique elements. It will just keep one unique element. No, don't give both unique elements, but you can give enough input arguments so in order to get unique rows and unique columns. So since we are talking about different particles along rows, so if any two coordinates, two particles are same, we want it to give a matrix without the third or other same extra coordinates. So when we do this, so what would be lost and how would you just make a reason true, make it this loop start if two coordinates are same, position coordinates or two particles are same. So they would be logic like would be like this. So what would be the size of V along the first dimension, row dimension would be 3. Let's say for 3 particles would be 3 cross 3. Let's say for only first dimension row it will be 3. If there is a two unique rows, the size of U would increase. So size of U would be less than 3. So you can say that if size of UN along first dimension is not equal to size of V along first direction, logic is equal to true, and this loop will stop. Okay, I don't think this is small. Let's keep small bounds and see what happens. Yes, they are not colliding yet. Let's wait. Oh my god, they are not colliding. Just increase number of particles. Let's increase number of particles. Keep it as 5. Okay. Okay, they did collide from particles 5. The number of particles are only 3. Now 4. 1, 2, 3, 4. So 2 particles did collide. If you want to see which are the particles that collided, so you can see from V matrix here. So particle 1 and particle 4 is colliding. Okay, this works very nicely. So you can increase the bounds, increase the number of particles by just increasing those two things. Let's see. Yeah, the particles have increased. They are randomly moving. So this was the aim of this video. And they should stop, this loop should stop when two particles or more than two particles collide. They're not colliding yet. Oh my goodness. Let's wait, they will collide at some time because the space is too much and the unit displacement for every state is 1. So there is a possibility they will collide. Oh my god, they are not colliding. Okay, they did collide now. Long time they are colliding. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 particles to have been collided. If you want to see two particles that have collided or particles, it would be which one out there? 17, 14. This one, particle 1 and particle 10 has collided. So I think this is it for this video. The objective has been completely covered. In the next video, let's see what we can do. You can also actually message me on my Twitter handle and give me some challenging problems which we can actually solve together. Okay, this is it for this video. Thank you for watching.